So time, speed, and distance. So when we talk about time, speed, and distance, the question which comes in our mind that only one formula. The formula is distance is equal to speed into time. This is the formula which comes in our mind whenever we hear this topic called time, speed, and distance. Um, we can understand this topic as such, like there are many subtopics are there based on this topic. Like you can talk about problem on train, you can talk about boats and steam, you can talk about race and games. In race and games you can talk about linear race, circular race, concepts on relative speed. Lot of concepts are there which are totally based on this formula called distance is equal to speed into time. So when we talk about this formula called distance is equal to speed into time, I can I can represent my distance. I can represent my distance in kilometer. If I am representing my distance in kilometer, will prefer to represent a speed in kilometer per hour and the time in hour. Or I can represent my distance in meter. If I'm representing my distance in meter, then my speed will be meter per second and my time would be seconds. So this is a basic terminologies what we use in this chapter called distance is equal to speed into time, where generally we represent our distance in kilometer, speed in kilometer per hour, and time in hour, or we talk about where we represent the distance in meter, speed in meter per second, and time in second. Where the relationship what we know about hour, minute, and second, that 1 hour is equal to 60 minutes, 1 minute is equal to 60 seconds. So we can say that 1 hour is equal to 600 seconds. So this is the relationship which we can adjust between hour, minute, and second. Gradually, we know that 1 kilometer is equal to 1000 meters. Okay, we can say that 1 mile is equal to 1600 meters. We can remember this. And to convert the kilometer per hour into meter per second, if you multiply the kilometer per hour with 5 by 18, you will get the value in meter per second. Similarly, you can convert meter per second into kilometer per hour by multiplying it with by 18 by 5. So if you multiply meter per second with 8 by 18 by 5, you will get the value in kilometer per hour. So you can remember them as your relationship to convert the speed if it given in kilometer per hour into meter per second. And similarly, if you speed, if it given in meter per second into kilometer per hour, so that relationship you can always remember for the conversion part. Here, if you see this question, a train runs at 45 kilometer per hour. How far does it go in 6 seconds? So here I am asking you the distance. The speed is in kilometer per hour, and your time is in second. So you cannot multiply them like that because they are in different unit. So you need to put them in same unit. Either you need to convert the speed which is given in kilometer per hour to meter per second, and then you can get the answer in meter. The distance you'll get in meter. Or what you can do, you can convert the time what is given in second into hour so that you can get the distance so that you can get the distance is in kilometer. So it depends upon what is your objective. Here if you see in the options all the distance, all the options what is given, they all are given in meter. So the best way what we can do is to convert the distance in meters. So if we can do that, then 6 threes are 18 and 3 is 45. So I'll get the value of distance in meter as 75 meter. So the answer would be option D. So here in this problem it is given that the train runs at 45 kilometer per hour. How far does it go in 6 seconds? Here I can find my distance either in meter or I can find my distance either in kilometer. So, but if you observe in the option, all the options were given meter. So that would be better if you can convert our speed, which is given in kilometer per hour, into meter per second, and then probably we can find our distance in meter. So I hope everyone understood this. Then I can talk about few more numerical based on the same concept. Maybe there's a question I can say that suppose there's a race happening between car and train, and the race is of 75 kilometer. There's a 75-kilometer race between car and train. So suppose there is 75-kilometer race between car and train. Suppose a 75-kilometer race between car and train. Okay, and it is given that the speed of train. So it is given in the problem. Suppose speed of train is 50%. It is given the problem that the speed of train is 50% more than the speed of car. It is given that the speed of train is 50% more than the speed of car. Suppose there's a race happening between train and car, and it is given that the speed of train is 50% more than the speed of car. Okay, fine. So both train and car, both train and car started, both train and car started at the same time. So both train and car started at the same time. Both train and car started at the same time from point A. Both train and car started at the same time from point A toward the point B, towards the point B. So both train and car started at the same time from point A toward the point B. Okay, both of them started same time from point A toward the point B. Okay, so both train and car started same time from point A toward the point B. Okay, uh, that given that train in between. It is given that the train in between stopped for. It is given that the train in between stopped for 12.5 minutes. It is given that the train in between stopped for 12.5 minutes at one of the station. At one of the station. So it is given that the train in between stopped for 12.5 minutes at one of the station, but car never stopped. But car did not stop anywhere. Car did not stop anywhere. Car did not stop anywhere. Okay. So both both train and car, both train and car reached reached the finishing line or whatever the point B. Both train and car reached point B at the same time. At the same time. Okay. So find the speed of train. Find the speed of train. Find the speed of train. Suppose this is the question. I'll repeat this question. So there's a race is happening between train and car. Okay, and it is given that the speed of train is 50% more than the speed of car. So the distance what they need to cover, the distance what they need to cover is 75 kilometer. And let the speed of let the speed of let the speed of let the speed of car is suppose 8 kilometer per hour. Okay, then the speed of train, it is given that the train speed is 50% more than the speed of car. It is given that the train speed is 50% more than the speed of car. Then the train speed would be 1.5. I think everyone can understand this. So the speed of train is 50% more than the speed of car. The speed of car was given A. So the train speed is 50% more than A. So the speed of train would be 1.5 A, or you can say that the speed of train is equal to 1.5 A or 3 by 2 kilometer per hour. Okay. So both train and car, there's a race is happening between them. The speed of train is more, and both are covering the same distance. So automatically, you can understand that the train will take less time than the car to cover the same distance. It is very generic concept what I'm discussing here. So if both train and car are covering the same distance, and the speed of train is more than the speed of car, definitely the train will reach the finishing line before the car. That everyone can tell. Distance is equal to speed into time. If distance is constant, whichever is having more speed, automatically that one will reach earlier. But here, what is happening? Both are starting from the same time and from the same time at point A, and both are reaching B also at the same time. So why this is happening? Because the train has stopped for 12.5 minutes at one of the station. That's why both are reaching B at the same time. So here I assume the speed of car is 8 kilometer per hour, and the speed of train is 3 by 2 8 kilometer per hour. That I got the value. So the what is the time taken by car? What is the time taken by car to cover 75 kilometer? So the time taken by car to cover 75 kilometer, that will be 75 by a hour. Okay, that will be 75 by a hour. And similarly, I can find the time taken by train to cover 75 kilometer. So then I can find the time taken by train to cover 75 kilometer. That will be 75 by 3A by 2. Okay. And how much time the train is taking? This much time, but in between the train has stopped for 12.5 minutes at one of the station. So you can write this 75 by 3A into plus 12.5 minutes. Everything is time and all. If you observe, I'm taking in hour, so I can convert this into hour. So now I can solve this. This is 25, so I can write this as 50 by A, and this, that is 125 by 600. 125 by 600, I can solve it. 125 by 600, if I divide by 25, so this will be 5 za, and this will be 24 za. So I can say that this value, I can say that this value will be 50 by A plus 5 by 24. So this value which is given in hour, this will be equal to this value, because it is given that both train and car, they started at the same time and both reached the point B also at the same time. So the time what taken by car never stopped anywhere. So and suppose the car speed is 8 kilometer per hour. The distance between train and car, the distance between point A and point B is 75 kilometer. So the time what the car is gonna take is 75 by 8. Simple. And the whatever the time the car is taking, the same time the train is also taking, although the train is running fast, because the train is stopping at one of the station for 12.5 minutes. So that difference 12.5 minutes is, the 12.5 minute is actually the time difference between the time what the train takes and what the car takes. So that is the difference, what is 12.5 minutes. That's why both train and car are reaching the finishing line at the same time. So what is the total time taken by train to reach the point B? That would be nothing but the distance, which was 75 kilometer, divided by the speed of train. So plus 12.5 minutes, because 12.5 minutes the train stopped at one of the station. Now you just need to equate this. So suppose this is equation 1, and suppose this is equation 1, suppose this is equation 2. So you just need to equate them. So if you equate equation 1 and equation 2, so you can have 75 by A is equal to 50 by A plus 5 by 24. So if you just bring it here, 75 by A minus 50 by A equal to 5 by 24. So this is 25 by A equal to 5 by 24. You can solve this. This is 5. So the value of A is 24 5, that is equal to 120 kilometer per hour. So you get the speed of car as 120 kilometer per hour. So you get the speed of car as 120 kilometer per hour. So once you get the speed of car as 120 kilometer per hour, then automatically you can find the speed of train. Train speed is 50% more than 120. So automatically, if you solve, you will get 180 kilometer per hour. So this is a basic question I thought to give or to discuss this concept more. The problem on time, speed, and distance. The discussion of this equation, the equation based problem, like distance is equal to speed into time. Distance is equal to speed into time. So when we talk about distance is equal to speed into time, if distance is constant, if your distance is constant, then your speed will be inversely proportional to the time. Okay, so then your speed will be inversely proportional to the time. So you remember in percentage chapter I told you that if product of AB is constant, it means if A is inversely proportional to B, then you know that if A will increase, then B will decrease, and if A will decrease, then B will increase. So same logic, if distance is constant, then your speed and time are inversely proportional. So then you can remember 1 by x increase in speed will give 1 by x plus 1 decrease in time, and 1 by x decrease in speed, and 1 by x decrease in speed will give 1 by x minus 1 increase in time. So remember the relation between time, speed, and distance, that if your speed increase by 1 by x, then your time will decrease by 1 by x plus 1 to keep the product constant. And while if your speed decrease by 1 by x, then your time will increase by 1 by x minus 1 to keep the product constant or to keep the distance constant here. So product is the distance. Remember this relationship. Already I told this relationship in percentage chapter also. So similarly, I can say that if speed increase by r percentage, then time will decrease by r by 100 plus r into 100%. Your time should decrease. Okay, now to keep the distance same. And if speed decrease by r%, then time should increase by then your time should increase by r by 100 minus r into 100% to keep the product constant, to keep the distance same. So this relationship is very important. So this relationship will work whenever your distance is constant, and whenever your distance is constant, your speed and time are inversely proportional. So you can remember this relationship. Based on this, in exam and all, you definitely get a question like if I ask you this question, walking at 3 by 4 of my original speed, walking at 3 by 4th of my original speed, walking at 3 by 4th of my original speed, I reached my office. I reached my office. Walking at 3 by 4th of my original speed, I reached my office. Suppose 16 minutes late. So walking at 3 by 4th of my original speed, I reached my office 16 minutes late. Okay. So what is the usual time to reach office? What is the usual time to what is the usual time to reach office? Suppose this is the question. What is the usual time to reach office? So walking at 3 by 4th of my original speed, I reached my office 16 minutes late. What is the usual time to reach office? So to solve this question, how you can solve many ways you can solve it by traditional way. Let my speed is x, okay, and let the then the time is y minute. Let my speed is x kilometer per minute, and then my time would be y minute. If I'm walking at 3 by 4th of x, okay, then I'm taking 16 minute late, so I'm taking 16 minute more. So you can simply solve this, equate this equation. So x and x will get cancelled, and we can write this. This will become 4y is equal to 3 into y plus 16. So we can write 4y is equal to 3y plus 48. So y is equal to 48 minutes. That is a one way to get the answer, and it is very simple way to get the answer. That is a one way to understand the concept. The other way, the same concept you can understand like this way. Then walking at 3 by 4th of my original speed. So earlier, suppose my speed was x. Suppose my speed earlier was x. Now I'm walking at 3 by 4x. So what is my decrease in speed? So what is the decrease in speed? The decrease in speed is x minus 3 by 4x. That means my decrease in speed is x by 4. I hope you can understand. 3 by 4 is nothing but 75%. So you're walking at 75% of your speed. You're not walking at 100% because you're walking at 75% of your speed. That's why you are getting late for the office. So walking at 3 by 4th of my usual speed, I reach my office 16 minutes late. So walking at 3 by 4th of my original speed. So now I'm actually walking at 75% speed. My speed is actually 1 by 4 less. So if my speed is actually 1 by 4 less, then my time to reach office will increase by 1 by 3. So because if your speed decrease by 1 by x, your time will increase by 1 by x minus 1. If your speed increase by 1 by x, your time will decrease by 1 by x plus 1. So here your speed is 1 by 4 less, so your time will increase by 1 by 3 more. And that 1 by 3 more, what your time increased, that is given to you as 16 minutes. So what is your usual time? 16 3s are 48 minutes. This part, I believe everyone understood this. So what is the usual time to reach office? That will be 48 minutes. So anyway you'll do, you'll get the same answer. So remember this relationship in case if you get a problem. Okay. Then you may get a problem like if I'm going office, if I'm going office 3 kilometer per hour. If I'm going office at 3 kilometer per hour, then I will be late for office. I will be late for office. Then I will be late for office by maybe suppose 10 minutes. Okay. I late for office by 10 minutes. While if I go at 4 kilometer per hour, while if I go at 4 kilometer per hour, I will reach office 5 minutes early. Suppose I will reach office 5 minutes early. Okay. What is the distance between what is the what is the distance between what is the distance between what is the distance between home and office? What is the distance between home and office? Suppose this is the question. So if I'm going to my office at 3 kilometer per hour, I'm actually late by 10 minutes. While if I'm going my office at 4 kilometer per hour, then I'll reach my office 5 minutes early. So what is the distance between my home and office? So the very common question, one of the question which you find always repeated in time, speed and distance chapter. Time, speed and distance chapter is actually very predictable chapter. If you go by the traditional mindset, the questions are very much predictable in nature. The more innovations what you can find in time, speed, and distance chapter is actually the concept of race and games. If you want, I'll give you around 2 hour video on race and games. If you want, I'll give you the link for that. You can solve more questions of race and games, and that will actually help you a lot where you get a problem based on linear race and circular race. You can solve those questions. Getting yourself very good with these concepts is the need of the current era time. Otherwise, these are traditional questions which you'll always find, and such exams which will not focus more on innovative problems. They will go with these traditional mindset kind of questions, and you can do them very easily. The shortcut formula is available for all these concepts, because as you know that this topic is very old, so you have lot of shortcuts rotating around this concept. So like if I'm going office at 3 kilometer per hour, so you can see this, your speed is 3 kilometer per hour. If you're going at 3 kilometer per hour, then you are late by 10 minutes. You are 10 minute late. Okay, you are 10 minute late. Okay, while if you're going at while if you are going at 4 kilometer per hour, while if you are going at 4 kilometer per hour, while if you are going at 4 kilometer per hour, you are 5 minutes early. 5 minutes early. So if you understand what is the difference in time, what is the difference in time given in the problem. So the difference in time, first you are 10 minutes late, then you are 5 minutes early. So the difference in time is 15 minutes. So if you want to find a distance, there's a shortcut formula, that is S1 minus S2 divided by modulus of S1 minus S2 into difference in time. This is a shortcut formula, difference in time. Because this question is very generic, so there's a shortcut formula available. You can simply use the formula and you'll get the answer. So the two speeds are given 3 and 4, and you can simply multiply 3 into 4, divide by t minus 4, and the difference in time is 15 minutes. You can talk in hours. So convert the minute into hours. This will be 12 divided by 1 into 15 by 60. I can simply solve this. So this is 12 5s are right, 60 and 5 3s are. Distance is 3 kilometers. Simple. So you can get the answer very easily by using this formula, shortcut formula. If you want step by step also we can get the same answer. But you should know shortcut, because everyone rest in the competitive world knows the shortcut. You can use this shortcut and you will get the answer in exam. Whenever you see the question on distance, you simply use the shortcut and your work will be done. So this is the formula. Otherwise, if you want step by step, I will tell you step by step. So let the distance between home and office is suppose in d kilometer. Let the distance between home and office is d kilometer. Okay, and if you are going at 3 kilometer per hour, okay, if you are going at 3 kilometer per hour, then whatever is your usual time, from that you are taking 10 minutes late. You are getting 10 minutes late. While if you are going at 4 kilometer per hour, while if you are going at 4 while if you are going at 4 kilometer per hour, then from your usual time you are 5 minutes early. Whatever is the usual time to reach office, you are 4 minutes early. You simply solve this by subtracting the equation 2 from equation 1. So d by 3 minus d by 4, dt will get cancelled. 10 by 60 minus minus plus 5 by 60. You simply solve this, take LCM 12. So 4d minus 3d is equal to 15 by 60. 15 by 60 is nothing but 1 by 4. So just solve this, d by 12 equal to 15 by 60. 15 by 60, 15 fours are 1 by 60. You can write as 1 by 4. So the d value is 12 by 4 or 3 kilometers. You can understand this. one of the question which comes, which repeated in many exams. So they twist and turn the question. I can give you in both the scenario. I am late. So when I'm moving at 3 kilometer per hour, then I'm 10 minutes late. When I'm moving at 4 kilometer per hour, I'm 5 minutes late. So what is the distance? So I can ask you anything. So I hope you're understanding. So here, when I'm walking at 3 kilometer per hour, then I'm 10 minutes late. Suppose then I'm 10 minutes late, and if I'm moving at 4 kilometer per hour, then I'm 5 minutes late. So what is the distance between my home and office? So again, you'll do the same thing to get the answer. Distance is equal to 3 into 4 divided by 3 minus 4. Take positive sign modulus. And what is the difference in time? Difference in time here will be 5 minutes. You can understand. First you are 10 minutes late, then you're 5 minutes late. What is the difference in time? Only 5 minute difference is there. You simply solve this. So what is the value you'll get? What is the value? 1 kilometer is the distance you'll get. Clear everyone? So you can solve this question, very traditional kind of question based on this. So you can easily solve this. So you know the formula here, that the formula what we use is distance is equal to speed into time. We know the formula. We talked about a formula where distance is equal to speed into time. So here, if I talk about average speed, if I talk about average speed is basically total distance covered. Average speed is basically total distance covered by total time taken. Average speed is total distance covered by total time taken. That is the formula of the average speed. That whatever is the total distance you are covering divided by the what is the total time you are taking. That is the usual formula of average speed. Okay, so in this formula you can understand one thing. In the average speed formula, like suppose if I give you the scenario that I'm going 6 kilometer at 4 kilometer per hour, and suppose the remaining 4 kilometer at 6 kilometer per hour. Suppose if I give you this problem and I ask you what is my average speed, what is my average speed, if I ask you what is my average speed, so you can solve this question. You can take the total distance. So what is your average speed? So average speed will be what is the total distance you cover? That is 10. Divide by what is the total time you took. So for 6 kilometer, you you are walking at 4 kilometer per hour, and for 4 kilometer you are walking at 6 kilometer per hour. So what is your average speed? That would be 10 divide by 3 by 2 plus 2 by 3. Okay, so you can solve this. This is 10 divide by 9 plus 4, 13 by 6, 13 by 6. So that is 60 by 13 kilometer per hour. That is your average speed. So I hope you're understanding. It's around 4 point something. So 4 8 by 13. That is my average speed. So I just use the formula average speed as the total distance covered by total time taken, and with that I'll get the answer. What is the average speed? So the average speed is total distance by total time taken. I got the value of the average speed here. So I hope you are understanding this concept. Here, the shortcuts you remember in average speed concept, that if d1 is equal to d2, so the distance, like the distance what you are covering, suppose just both the distance are same. Here, if both the distance is same, and this is x kilometer per hour, and if suppose this is y kilometer per hour, the speed is y, x and y. If the distance is same, suppose the distance is d kilometer, okay, and the speed when you're moving at d1 kilometer is x kilometer per hour, and the speed when you're moving at the speed at which when you are moving for under d kilometer, suppose y kilometer per hour, So the average speed here will be the average speed here will be, you can remember, that will be 2xy divided by x plus y. Remember this. It follow harmonic mean. In the first semester in statistics, you studied all this. So remember this. So average speed don't follow arithmetic mean, saying that the average speed is x plus y divided by 2. This is a shortcut formula. Imagining that you are covering the same distance, then you can directly find the average speed with this formula, 2xy by x plus y. How you got this? So you know that average speed is actually total distance by total distance covered by total time taken. You know the formula, average speed is total distance covered by total time taken. So suppose first you cover d kilometer, again you cover d kilometer. Total time first, the time what you will cover will be d by x. Then the time what you will cover will be d by y. So you simply need to solve this. This is 2d divided by d 1 by x plus 1 by y. So your your average speed here, if you calculate your average speed dd will get cancelled, so that would be x plus y divided by xy. So your average speed will be 2xy by x plus y. This is this formula I told you in other way. You can use harmonic mean, so you can understand this. That is a shortcut formula. So if you are moving from point x to point y, if you're moving from point x to point y at d1 kilometer per hour, and again you're coming back from y to x at the speed of suppose d2 kilometer per hour. Okay, so then your average speed is as same as if you're covering point x to z at d1 kilometer per hour, and from Z to Y at D2 kilometer per hour. Suppose your distance is same in both the case. Your distance should be same in both the case. Then your average speed is nothing but then average speed would be 2d1 d2 divided by d1 plus d2. Simple concept which you can use to get the answer. Clear everyone? So you can use this concept and you will get the answer very easily. Imagine if I give you three speed, like suppose x, this is x kilometer, this is x kilometer, this is x kilometer, and suppose this is a kilometer per hour, this is b kilometer per hour, this is c kilometer per hour. So three distance, all three are same. So what is your average speed? So your average speed here, it will be 3 abc divided by ab plus bc plus ca. So this the logic of harmonic mean you can use only when you can use only when the distance is same. So the two intervals of the distance is same. You can directly find average speed by using the concept of harmonic mean. So I hope you understood this. Then going further, when we talk about going further here, when we talk about another concept that is called as relative speed. That is called as relative speed. So when we talk about relative speed, in case of relative speed, we'll talk about the motion of two objects. So whenever we are talking about motion of two objects, so it can be that the two objects are moving toward each other. Like this object is moving at a kilometer per hour, and this object is moving at b kilometer per hour, and the distance between them is x kilometer. Okay, so what is the relative speed? The relative speed between them, it will be a plus b kilometer per hour. Similarly, it can be the scenario when similarly it can be the scenario where the distance is x kilometer, okay, and this is moving at b kilometer per hour, and this is moving at a kilometer per hour toward b. So if the two objects move in same direction, so if the two objects move in same direction, then if A is more than B, so then only the object A can catch the object B. If the speed of object A is more than the speed of object B, so then their relative speed will be A minus B kilometer per hour. So you can use this and you can get the answer between them very easily. If the two objects move in opposite direction, then the relative speed will be A plus B. While if the two objects move in same direction, then the relative speed will be A minus B. You can use this concept and you can solve many problems based on this concept very easily. So anyone any doubt with this, you can prove it by the AP or any other logic. So let the distance between two objects is suppose 100 kilometer, and one object is moving toward the another object at 20 kilometer per hour. So so you can see let the distance between the two objects is 100 kilometer, and suppose this object is stationary here and this object is moving toward this object at 20 kilometer per hour. So how much time it will take to reach this point? That would be 5 hours. Okay, you can understand it. Now next thing, suppose this object is not stationary. Suppose this object is moving in the same direction at 30 kilometer per hour. Now suppose this is A, this is B. So suppose B is running at 30 kilometer per hour and A is running toward B 100 kilometer backward, uh, and A is running at 20 kilometer per hour. Then in this case, A will never able to catch B. Okay, so you can understand very easily. So at time is equal to 0. So the distance between A and B is 100 kilometer. So after 1 hour, the A would cover 20 kilometer. Okay, now the distance between them should be 80 kilometer if B is same at that place, but B is not same at that place. B has covered 30 kilometer. B has covered 30 kilometer. B has covered 30 kilometer. So now the distance between them will become 110 kilometer. Again, after 2 hours, A has covered another 20 kilometer. So now this should become 60. But B is not at here. B covered another 30. So now the distance between them become 120 kilometer. Okay, so you can understand here. So you can understand here that if you calculate the relative distance, the difference will be always 10 kilometer. How you find that 10 kilometer? You can easily understand. So the relative gap, what is developing between the two person, that will ultimately depends upon the difference in speed between the two person. So you can understand this very well. This follows AP, arithmetic progression. I believe you know AP. AP means when the number increases or decreases with the constant difference. So nth term in AP is A plus n minus 1 into D, and sum of n terms in AP is n by 2 into 2A plus n minus 1 into D. By this, okay. So if this object, if this A want to catch B, then the speed of A should be more than the speed of B. Okay, so in this case, the relative speed between A and B is minus 10 kilometer per hour. So here, if you see this relative speed between them is minus 10 kilometer per hour. Okay, so that's why every time at every interval of the time, the B will make a lead of 10 kilometer over A. So you can understand this concept. You can spend more time, you can do more research. Ultimately, you will get the same answer, as much research as you can. Okay, so while if you understand the other way, while if you understand by the other way, that suppose if B is running at 20 kilometer per hour and A is running at 30 kilometer per hour, so now the relative speed between them would be 10 kilometer per hour. Okay, so now the relative speed between them would be 10 kilometer per hour, and if you find the distance between them at time is equal to 0, the distance between them is 100 kilometer. After 1 hour, the distance between them will become 90 kilometer. After 2 hours, the distance between them will become 80 kilometer. Ultimately, after 10 hours, A will able to catch the B. So you can understand this part. While if the two objects they move in opposite direction, while if suppose B is running toward A at 20 kilometer per hour, so automatically the relative speed between them now the relative speed between them will become 50 kilometer per hour, and they will meet each other after 2 hours. You can understand this. So let's see this question number 2. So Aman start from a place at 7 a.m. with the speed of 10 km per hour. Rahul start from the same place at 9 a.m. with the speed of 15 km per hour when the Rahul meet Aman. So here you can understand Aman started from the place at 7 a.m. with the speed of 10 km per hour. So when 9 a.m. when the Aman and Rahul they are moving each other in the same direction. So you can understand Aman is moving at 10 km per hour and Rahul is moving at 15 km per hour. And Rahul started chasing Aman at 9 a.m. So and Aman was moving at 10 km per hour. So by the time Rahul tried to chase Aman, by that time the relative distance between them became as 20 kilometers, and both are running in the same direction. So both are running in the same direction. So the relative distance between them is 20 kilometers, and both are running in the same direction. So the relative speed between them will be 5 kilometers per hour. So the time what the Rahul will take to catch the Aman will be 4 hours. 4 hours after 9 a.m. means Rahul will catch the Aman at 1 p.m. You can understand that. So when Rahul will catch the Aman, both will cover the same distance. So the distance will be how much? Around 60 kilometers. Because Rahul has walked for 4 hours. Rahul has walked for 4 hours while the Aman was walking from 6 hours, from 7 a.m. to 1 p.m. You can understand while Rahul has just walked for 4 hours from 9 a.m. to 1 p.m. So the distance what both of them have covered is 60 kilometers. So you can use the concept of relative speed to solve many problems. The problems are related to the usual problem of time, speed, and distance, or you can use the same application in solving the problems on boats and steam. So when we talk about boats and stream, there we use two concepts. One is called downstream in boats and stream. One is called downstream, and the another one is called upstream. So downstream basically means when we say downstream basically means that when the boat and the water, when the boat and the water they move in the same direction. So downstream means when the boat and water they move in the same direction. We call this as a downstream. While what is upstream? Upstream means when the boat is moving, when the boat is moving against the water speed. That is called upstream. When the boat is moving against the water speed, that is called upstream. So when we talk about upstream, when we talking about upstream, then in the case of upstream, we need to move against the water speed. So automatically that means that our speed should be more than the water speed. Then only we can move against the water. So you can easily understand this concept. So in boats and stream, we are talking about in boats and stream. When we are talking about boats and stream, we are talking about two concepts of downstream. We are talking about the concept of downstream. We are talking about the concept of upstream. So you can understand the in downstream and upstream. We are actually using two variables. We are using two variable here. One variable is the speed of boat. One variable here is the speed of boat in still water. One variable is the speed of boat in still water. Suppose that is x kilometer per hour, and the another variable we are using is the suppose the speed of water. The speed of water is suppose y kilometer per hour. So the speed in downstream, when we talk about downstream, so the speed in downstream, then it will be x plus y kilometer per hour. Then the speed in downstream will be x plus y kilometer per hour, because both boat and water both are moving in same direction. So then the speed in downstream will be x plus y kilometer per hour, while your speed in upstream will be x minus y kilometer per hour, because here the water is moving against the boat. Because the water is moving against the boat, and if the boat want to move against that, then the boat should move at the higher speed than the water. That is what we study in upstream. So based on this, you get lot of problem in exam to solve, and you can use the concept for boats and stream to solve these questions. So you can see this, a men can row upstream at 10 kilometer per hour. So means x minus y, that is 10 kilometer per hour. Okay, so where x is the speed of boat in still water, y is the speed of water, that is upstream speed, and x plus y. So downstream at 16 kilometer per hour, you can solve this. 2x is equal to 26, so x is equal to 13. If x is equal to 13, then y is equal to 3. This is a shortcut formula if you want the boat in upstream and downstream. If it given you want to speed of boat in still water, then add the upstream speed plus downstream speed, divide by 2. And if you want the speed of water, then upstream speed and downstream speed, if it's given, then you should do downstream minus upstream divided by 2. Now you can see this question number 2. Suppose the stream is running at 2 kilometer per hour, means y is 2 kilometer per hour. A motor boat goes 10 kilometer upstream. You want the speed of motor boat, right? So let the speed of motor boat, it is x kilometer per hour. So what is the speed in upstream? Then what is the speed in upstream? Then it will be x minus 2 kilometer per hour. And your speed in downstream, then what is your speed in downstream? So then it would be x plus 2 kilometer per hour. Okay, so a motor boat goes 10 kilometer upstream, so 10 by x minus 2, and come back to starting point. So it means when it is coming back, then it will come back in downstream. It went in upstream, and if it try to come back, it will come back in downstream. The time what it will take is 55 minutes. So convert the 55 minutes in hour. So here, so this is 11 by 12. This is 11 by 12. So you can solve this. This is x minus 2 into x plus 2. This is 10 into x plus 10 into x minus 2 is equal to 11 by 12. You just need to solve this. This is 10x, 10x plus 20. This is 10x minus 20 divided by x square minus 4 is 11 by 12. So 20 get cancelled. So you can write 11 into x square minus 4 is equal to 240x. Then you'll get 10x plus 10x 20x into 12. So you'll get 240x. Then you'll get 11x square minus 44 is equal to 240x. So you'll get a quadratic equation. 11x square minus 240 minus 44 is equal to 0. 11 into 44 is 484. So break the middle term, 244, and break the middle term. In such a way, you break the middle term. In such a way, 354 break the middle term. You need to solve this quadratic equation. So you need to solve this quadratic equation to solve this. So either you try to break the middle term. If I see this, you are getting a factor called 484. I divide by 2, get 242, divide by 2, 121, then 11 and 11. 1, 121, 242, 242 and 2. Okay, so you can write this 11x square minus 2x plus 2x. 42 minus 44 is equal to 0. So you can write 11x, you can take common. This is x minus this is what 11 divided by 240, 22, right? Plus you can take 2 common. This is x minus 22 is equal to 0. So you'll get the x value as 22 kilometer per hour. So the x value is 22 kilometer per hour. Simple. So boats and stream, you can solve it very easily by using these concepts. So you can see question number third. The speed of boat in still water is 11 kilometer per hour. Speed of stream is 3 kilometer per hour. So your downstream speed will be 14 kilometer per hour and your upstream speed will be 8 kilometer per hour. The motor boat takes 11 hours to cover a distance up and down a fixed destination. So, so distance is suppose x kilometer per hour. It went upstream and then came back in downstream, or it went downstream, came back in upstream. So the total time will be x by 14 plus x by 8 is equal to total is 11 hour. You can solve this. Take an LCM. LCM will be 56. This is 4x plus this is 7x is equal to 11. You can say 11x by 56 is equal to 11. The value of x is 56. You can understand this concept of boats and stream, and with this you can solve the problems which are related to the concept of boats and stream very easily. Similarly, we can use the concept of relative speed whenever we are trying to solve the problem on train. So whenever we talk about train problem, so here we consider, whenever we are talking about train problem, we consider the length of the train. We consider the length of the train. If the length of train is given, we'll consider the length. We consider the length of the bridge. We consider the length of the bridge. We'll consider the length of the platform. We consider the length of the platform. While solving the problem on train, we consider the length of the train. If it's given, we consider the length of the bridge. If a bridge is given, we consider the bridge length. We consider the length of the platform, but we do not consider the, the length of the person. Person is given and we do not consider the length of the person or the length of electric pole, something like this. Based on this, we try to solve the problem. So on train, you can understand this while we try to solve problems. So you can see this question number third. A train. So you can see this question number third. You can see this problem. A train of length 150 meter. A train. So the length of the train is 150 meter. A train of length 150 meter long is running at 60 kilometer per hour. So the speed of the train is 60 kilometer per hour. Takes 30 seconds to cross the bridge. So let the length of bridge is b meter. Let the length of bridge is suppose b meter. So a train is there which is 150-meter long. It is running at 60 kilometer per hour and it's crossing a bridge of length b meter. So the total distance what the train has to cover, the total distance to be covered by train. So when we talk about train, what is the total distance? What the train has to cover? The train has to cover its own length plus the length of the bridge. I hope you are understanding this. And the speed of train is given in kilometer per hour. Normally, when we are solving the problem on train, we prefer to keep our data in meter and second. So 60 kilometer per hour. I can convert this into meter per second. So this is tenza, this is threeza. So this is 50 by 3 meter per second. Okay, and the time is given as 30 seconds. So the time is given as 30 seconds. So I just need to use the formula to get my answer. So the distance what the train is cover is 150 plus b. The speed of train is 50 by 3 meter per second. And the time what the train is gonna take is 30 seconds. So the time what the train is gonna take is 30 seconds. So you just need to solve. So this is tensor. You'll get as 500. So the value of the length of the bridge you will get is 350 meters. Anyone, any doubt? You can easily solve them. So the problem with trains, whenever you are getting, there you just need to remember few things that we consider the length of the train, we consider the length of the bridge, okay, we consider the length of the platform, but we do not consider the length of a person or electric pole. And based on this, we can solve the question very easily. So you can see this question. You can see this question. A train moving at uniform speed take 20 seconds to pass a cyclist riding at 11 kilometer per hour, but only 9 seconds to pass the post. Very good question. You can understand this. So the train is there. So let the length of the train, let the length of the train suppose L meter, let the length of the train is L meter. Okay, this train took 9 seconds to pass electric post. Okay, this train is gonna take 9 seconds to pass electric post. Okay, so you can formulate an equation that L is equal to, suppose the speed of train is x meter per second. So into 9. So this is your first equation. Where let the speed of train, let the speed of train train is meter per second. So assume let the speed of train is x meter per second. So with this you can write the equation L equal to 9x. So let the length of the train is L meter. This train took 9 seconds to cross electric post. So when we talk about electric post, we are not considering the length of the electric post. And here, why the train took 9 seconds to cross the electric post? Because the train has to cover its own length. So the time interval between when the front end of the train crossed to the when the front end of the train crossed the electric pole, then the last end of the train crossed the electric pole. The time interval here is 9 seconds. You can understand it. Now the same train is crossing the a person, a cyclist, the same train of the length L meter, the same train of the length L meter when it is trying to cross a cyclist. Okay, so imagine if the cyclist is stationary. Imagine if the cyclist is stationary, then the train would have been crossed the cyclist in 9 seconds. Why the train would have crossed the cyclist in 9 seconds? Because the same train took 9 seconds to cross the electric pole, and we do not consider the length of the electric pole, neither we consider the length of the person. So if the same train wanted to cross the person standing, then the train would have crossed this person in 9 seconds. Now, if this person, you know physics, you can understand the concept of relative speed, you can understand that if this person was trying to move toward the train, because this person is running at 11 kilometer per hour. Now, if this person would be running toward the train, then the time would have been less than 9 seconds. You can easily understand. Then the time what the train would have taken to cross this person would have been less than 9 seconds. But here it is given that the train is taken 20 seconds to cross this person. That means what? That means this person and the train both are running in the same direction. What that means? That means that the train is running toward this person as x meter per second, and this person is running in the same direction of the train with the speed of 11 kilometer per hour. I hope you understood this. I can write L is equal to x minus 11 into 5 by 18 to convert this into meter per second. And the time what the train took to cross this person is 20 seconds. In place of L, I can write 9x. This is 20 into x minus, this is 55 by 18. I can solve this. So 9x is equal to 20x minus 1100 by 18. I can write 11x equal to 1100 by 18. So you'll get the value of x is equal to 100 by 18 meter per second. Okay. Here in this problem, I need to find the length of the train. So the length of train is 9x. So the length of the train is 9 into 100 by 18. That is the length of the tree. Now try to do this question. You can try this question by yourself. Everyone, try to do this question. So you can see this. A train 110-meter long. A train 110-meter long. A train 110-meter long travel at 60 kilometer per hour. Travel at 60 kilometer per hour. In what time will it pass a man walking at 6 kilometer against the train? So against the train in the opposite direction. So the relative speed will be 66 kilometer per hour. We'll convert this into meter per second. So we need to find this time. So this is 110 is equal to 66 into 5 by 18 time that I need to find. This is 11 by 3. This is 10. This is 2. So the time is equal to 6 seconds. Then second equation. So again second equation 110. Now they're moving same direction. Relative speed will be 60 minus 6 means 54 kilometer per hour into 5 by 18 into t. So this you can solve. This is 18 threes. So this is 18 threes. So this is equal to 22. So the time would be 22 by 3 second or 7 1 by 3 second. Simple problem. I hope you understood this. Then you can see the next concept. What we need to discuss here is the next concept. What we need to use here or learn here is the concept of race and games. So when we talk about race and games, you can see this. in 100-meter race, A beat B by 20 meters. So in 100-meter race, A beat B. When A covered 100 meter, the B covered 80 meter. In 100-meter race, A beat B by 20 meter and C by 25 meter. And means when A has covered 100 meter, B has covered 80 meter and C has covered 75 meter. The B will beat C by how many meters same race? So means when B has covered means when B has covered 80 meter, C has covered 75 meter. Okay, so when B has covered suppose 1 meter, then C has covered 75 by 80 meter. I hope you understand it. Similarly, so when B has covered 100 meter, then C has covered how many meters? 75 by 80. And solve this. And solve this. This is 5 sir. This is 4 sir. Solve this. This is, you can find this value. So 75 5 sir will be 375. 375 by 4 meter. 375 by 4 meter. If you want the value 375 by 4 meter, if you want the value 5s are 375, then this is 9s are 9s are 15. 15 means 3s are 30. 30 means 93.75 meter. So understand this. So you can, or you can understand in 80-meter race, B beats C by 5 meter. So in 100-meter race, B will beat C by 5 by 80 into 100. You can find this value. You get 6.25 meter. The same thing what you can get here. So the same question. So in 100-meter race, A beat B by 20 meter and C by 25 meter. So B beat C by how many meter in same race? So when B reached 100 meter, C is at 75 meter. So when B will reach 100 meter, then where is C? So C is at 93.75 meter. So you can understand this, the concept of race and games. Then you can see the next question that you can see the next question here is that in 100-meter race, in 100-meter race, so A beat B by 20 meter of 4 seconds. So you can understand that when in 100-meter race, when A reached the 100 meter, the B has reached 80 meter. So A has beat B by 20 meters. So when A has reached 100 meter, the B has reached 80 meter. Now you need to understand the speed of B. So here you need to understand the speed of B. So now to cover the additional 20 meter, the B is gonna take 4 seconds. Means that if A has reached, when A has reached 100 meter, in the same time B has reached 80 80 meter. Okay. Now the total time what the A is gonna take here is t second for 100 meter. A is gonna take t second for 100 meter, but B will take additional 6 second more to cover 100 meter. Okay, so I hope you're understanding. So here, what you need to understand here, that to cover the additional 20 meter, the B is gonna take additional 4 more second. Okay, so with that you can find the speed of B. So the speed of B is 5 meter per second. You can find the speed of B as 5 meter per second. Now you can find the time taken by B to cover 80 meter. So the time taken by B to cover 80 meter, that would be 80 by 5, that would be 16 seconds. So in the time in which the B has covered 80 meter, in the same time A has covered 100 meter. So what is the time taken by A to cover 100 meter? That will be also 16 seconds, because you know that the time in which the B has covered 80 meter, in the same time A has covered 100 meter. So the time what the A take to cover 100 meter is 16 seconds. So what is the speed of A? The speed of A will be 100 by 16, 6.25 meter per second. Now the next concept what you need to understand here, the next concept what you need to understand is the concept of head start. Head start is actually, it means the advantage what I can give to my opponent, uh, then either in the term of distance or either in the term of time. So if I want the race to be end in dead heat basically means the two-person reaching the finishing line at the same time. That is called dead heat. If I want the race to be end in dead heat, so what I want, what I can do, I can give advantage to my opponent in the term of distance or in the term of time, and that we called as a head start. So in 160-meter race, if A allows B a head start of 10 meter, means A and B. So A is telling B that I'll run 160 meter, you run 150 meter. So A is giving 10 meters advantage to B. Okay, then the race will end in dead heat. Means if they run in this way, then the race will end in dead heat. Means both will reach the finishing line at the same time. It means 160 by A is equal to 150 by B. Let the speed of A is A meter per second. Let the speed of B is B meter per second. So I can say that A by B is equal to 16 by 50. This part, I think everyone is clear with this part. Okay, so the ratio speed of A and B 16x, 16 is to 15. They run another race of 400 meter. They run another race of 400 meter. Okay, and this time A has allowed a head start of 40 meters. Now A told B that let run a race of 400 meter where I'll give you head start of 40 meter. It means that A now will run 400 meter while the B will just run 360 meter. Okay, so now the question arise. Now the question arise here. Now the question will arise here that you know the ratio speed of A and B. So A speed is suppose 16x and the B speed is suppose 15x. That is the ratio speed you got. Okay. Now A and B where they are running a race where A is gonna run 400 meter and B is gonna run 360 meter. Okay. So now you don't know who's gonna win or lose the race. So I can find the time, how much time they are going to take. So let what is the time taken by A to complete 400 meters, that will be 400 by 16x, that will be 25 by x second. And I can find the time taken by B to cover 360 meters, that will be 360 by 15x, that would be 24 by x. Right? The x is some integer. So x is some integer or x is, so here when you see this value of x is some natural number. You can understand the ratio of the ratio speed of A and B. I got the 16 is to 15. So now there's another race is happening between A and B where the A is supposed to run 400 meter and B is supposed to run 360 meter. Let the speed of A is equal to 16x and then the speed of B would be 15x. So the time what the A is going to take will be 25 by x and B is going to take 24 by x, where x is any natural number. So with this you can understand that B will win the race. With this you can understand that B is taking less time, so B will win the race. So B will win the race. You can easily understand that B will win the race. Okay. So question now it comes that by how many meter the B will win the race. So B is finishing the finishing line in 24 by x uh, second. So by how much distance B will win the race. So now B will win the race. B will win the race. B will now win the race. B will now win the race by how many meter? That will be 400 minus. Okay, 400 minus what? The speed of A is 16x, and in 24 by x second, how much distance the A would have covered? So by 400 minus that much distance, B will win the race. You can understand this. So 16 into 24, you'll get, I think, 384. 16 fours is 64, then 384. Yeah. So 384. So this is 400 minus 384. This is 400 minus 384. So B will win the race by 16. So you know that B is gonna win the race. You know that B will win the race. Now to find by how many meter the B will win the race. So for this you can easily understand that because B is gonna reach the finishing line in 24 by x second. So in that time, how much distance the A would have covered? A is running at 16x meter per second. So the distance what the A would have covered, the time when the B reached the finishing line is 384 meter. It means A will lose the race by 16 meter. Okay, so this all we do like this kind of problem in race and games. You can try this question number 4 and question number 5. They're very easy problem. You can do by yourself. Linear race problem.